A galaxy with 400 billion stars is more than 99.9999% empty space. Not mostly empty, almost entirely empty. If you shrank the sun to the size of a grain of sand, the nearest star would sit 4 miles away across nothing. Galaxies look crowded in photographs because light gathers what distance hides. Tonight, we are going to walk through that emptiness slowly and feel what a galaxy actually is. If this kind of quiet science helps you drift, a like and a subscribe lets more sleepers find it. And before we begin, tell me softly in the comments where you are listening from and what hour it is where you are. Now, settle in. Picture the image you have seen 100 times. The spiral galaxy, the long pinwheel of light against the black of space. The luminous arms uncoiling from a bright core, dust lanes threading through them like dark rivers, the whole structure tilted just slightly so you can feel its rotation even in a still frame. You have seen it in textbooks, on posters, on the home page of every astronomy article you have ever opened. You may even have one saved on your phone. And when you look at it, your eyes tell you a story. They tell you the galaxy is full. They tell you the galaxy is crowded. They tell you that those arms are dense with stars packed shoulder to shoulder, that the core is a furnace of bodies pressed together, that if you could fly into the picture, you would find yourself surrounded on every side by burning suns. No room to move, no gap to slip through, light pouring in from every direction at once. Tonight, I want to slowly take that story apart. Not because the image is wrong. The image is not wrong. The image is one of the most honest things our species has ever made. It is the result of thousands of hours of careful observation, of patient calibration, of mathematics so refined that we can now measure the wobble of a star 1,000 light years away by the way its light flickers across our instruments. The image is honest. The image is real. And yet the image is misleading in a way that almost no one ever pauses to notice. Because the deception is not in the picture itself, but in what your eye does with the picture when it arrives. Let me say that again so it registers. The photograph is honest and the photograph is misleading. Both are true. These two facts are not in conflict. They are the same fact stated from two different distances. To understand why, you have to understand what a long exposure of a galaxy actually is. When an astronomer points a large telescope at a distant spiral, they do not take a single snapshot the way you would with the camera in your pocket. They open the shutter and they leave it open, sometimes for minutes, sometimes for hours, sometimes across many separate nights, for days. The light from the galaxy is so faint, so spread out, so diluted across the long corridor of space it has traveled, that a single instant of exposure would show almost nothing. A grey field. A few of the brightest stars in the foreground of our own galaxy. Maybe a faint smudge where the spiral should be. To bring the spiral into view, you have to gather, you have to wait. You have to let the photons accumulate, one by one, on the detector until the faint signal builds itself up into something the eye can read. This is what a long exposure does. It is a kind of patience made visible. It is light gathered across time and stacked into a single frame. And here is where the gentle deception begins. Because when the photons finally arrive in numbers great enough to render the galaxy, they do not arrive evenly. They arrive most densely from the places where the most stars are, and they arrive least densely from the places where the stars are sparse. The detector adds them up. The image processing pulls them into a visible range, and what emerges on the screen is a continuous sheet of light, smooth, glowing, almost cloud-like in its solidity, as if the galaxy were a sheet of luminous fabric stretched across the sky. But the galaxy is not a sheet of luminous fabric. The galaxy is a scatter of points across an ocean of nothing, and the long exposure has gathered the light from those points and smeared it together until the spaces between them disappear from view. The gaps are still there. The vast, cold corridors of vacuum between one star and the next are still there. They have not gone anywhere. They never went anywhere. They are simply not visible in the image, because the photograph has no way to render emptiness. A photograph can only render light, and light, in a long enough exposure, will paint over its own absence. Hold that for a moment. A photograph can only render light. So the photograph of a galaxy is a portrait of the lit places. The unlit places, which are nearly all of the galaxy, are invisible to the camera by design. They are not hidden, they are not concealed, they are simply not the kind of thing a camera can show. The way a microphone can record sound but cannot record silence in any direct way. The way a thermometer can register heat but cannot register the absence of motion in a substance. The instrument shows you what it is built to show you, and the long exposure of a galaxy is built to show you the stars. This is not a deliberate lie. It is a necessary one. It is the only way our instruments can render something that vast. To show you the galaxy, we have to flatten it. To flatten it, we have to gather its light into a plane. To gather its light into a plane, we have to compress hundreds of billions of separate sources into a single frame. And when you compress hundreds of billions of separate sources into a single frame, the empty space between them disappears, because the empty space had no light of its own to contribute. The frame fills with the brightness of what is there, and the eye, looking at the frame, reads the brightness as fullness. This is the lie your eyes tell you about a galaxy. It is a soft lie, a forgivable lie, a lie made of light. But it is a lie nonetheless, and tonight we are going to walk slowly through what it covers up. So let me give you the destabilizing claim now, in its fuller form with the measurements attached. The galaxy you see in the photograph contains somewhere between 100 billion and 400 billion stars. The Milky Way, our own galaxy, the one whose photograph you have seen rendered 1,000 different ways, sits comfortably in that range. The disk of the Milky Way is roughly 100,000 light-years across. The thickness of the disk is roughly 1,000 light-years. The stars in that disk are not packed together. They are not even close. The average distance between one star and the next, across most of the volume of the galaxy, is roughly 5 light-years. 5 light-years is a distance so large that the word distance begins to feel inadequate. 5 light-years is the width of a corridor of vacuum through which light, the fastest thing the universe contains, takes 5 years to travel. And that is the average distance. That is the median gap. That is what is between you and the nearest grain of sand. I will come back to that grain of sand. I am putting it on the table now so we can return to it later. If you take those numbers and you multiply them, if you add up the volume occupied by all the stars in the galaxy and you compare it to the volume of the galaxy itself, What you get is a ratio so small that it stops feeling like a ratio at all. The galaxy is more than 99.9999% empty space. Not mostly empty, not largely empty, almost entirely empty. The matter is the rounding error. The matter is the speck. The matter is the thin sparkle on the surface of a body of nothing so vast that we have to invent new vocabulary just to talk about how empty it is. And yet, in the photograph, the galaxy looks crowded, looks dense, looks full. Let that land for a second. The thing you are looking at when you look at a galaxy photograph is almost entirely an arrangement of empty space. The brightness you see is the rare exception. The dark between is the rule, and the dark between is so much larger than the bright that if you scaled the galaxy down to the size of something you could hold, the bright would be invisible. I want you to imagine, just to get a feel for what we are talking about, a single grain of sand sitting on a kitchen table, not a beach, not a handful, a single grain of fine sand, the kind that catches on your fingertip and you have to flick off, the kind so small you almost lose track of it when it falls. Place it on the table in front of you. That grain is the sun, the whole sun, with its plasma and its corona and its 11-year cycles and its planets in their long, slow orbits, including the planet you are sitting on right now, the planet under your chair, the planet beneath your feet. All of it compressed into a single grain of sand on a kitchen table. Now, where is the next grain? In a real arrangement of stars at the average density of the Milky Way disk, the next grain is not on the table. The next grain is not in the room. The next grain is not in the building. The next grain, at the scale of our model, sits about 4 miles away, 4 miles, across town, on someone else's kitchen table, in someone else's house, behind a closed door you have never walked through. And between your grain and that grain there is no second grain to find. There is no scattered handful of dust between them. There is no fine mist of matter drifting in the gap. There is only the kitchen, and then the street, and then the long, quiet space of city blocks and houses and lawns and stretches of road, all of it in our model empty. All of it in the real galaxy, mostly empty too. Hold that for a moment. That is the texture of the galaxy you are sitting in. 2 grains of sand, 4 miles apart, with nothing meaningful between them. And then, far beyond the second grain, a third grain, and beyond that a fourth, and beyond that a fifth, scattered out across distances that no kitchen and no street and no city can contain. And there are between 100 billion and 400 billion of them, arranged across a sphere 100,000 light-years wide, which is to say, in our scale model, across a region you would need a continent to draw and an ocean to fold around. And almost all of it, almost the entirety of it, is the gap, the space between the grains, the dark between the points. This is the picture I want you to carry with you as we walk. Not the photograph, not the luminous spiral with its bright arms and its dense core. The other picture, the truer picture, the picture made mostly of distance, the picture made mostly of nothing. I want to say one more thing before we move forward, because I do not want you to feel that I am tearing the photograph down out of some need to deflate it. The photograph is not the enemy here. The photograph is one of the great achievements of our species. We did not always have it. For most of human history, the galaxy was a smear of light across the night sky, a band of milky brightness our ancestors named in their own languages, in their own stories, with their own gods walking along it. The understanding that the smear was a structure, that the structure was a disk, that the disk contained an unimaginable number of stars, that those stars were arranged in a spiral, that the spiral had arms and a bar and a halo, that the whole thing was rotating, that we ourselves were inside it and looking out. All of that took centuries of patient work by people whose names you may or may not know, but whose careers were spent in quiet rooms with delicate instruments and very long nights. I am thinking, just now, of a woman named Henrietta Swan Leavitt, who worked at Harvard in the early years of the 20th century, in a room with other women who were called computers, because their job was to compute by hand, on paper, the brightnesses of stars recorded on glass photographic plates. Leavitt looked at one particular kind of variable star for years. She measured the way its light pulsed, the period of its rhythm, the way the period correlated with the absolute brightness of the star. And from that quiet, patient work, from those long hours in that room with those plates, she gave us a measuring stick we could use to figure out how far away other galaxies were. She did not see what we see. She did not have the photographs we have. She had glass plates and a magnifying lens and the patience to count and count and count and count again. And we are standing on her shoulders right now. We are standing on the shoulders of many people like her. So when I say the photograph is misleading, I do not say it with disrespect. I say it with the kind of gentle care you would have for an old map that is mostly accurate but compressed in places, that shows you the shape of the coastline but cannot show you the texture of every cove. The photograph is the map, and the map is not the territory. And tonight, slowly, we are going to walk into the territory. Here is the promise of the walk. We are not going to rush. We are not going to skip the difficult parts. We are not going to compress the distances for our own comfort. We are going to take the grain of sand on the table, and we are going to ask what it means that the next grain is 4 miles away. We are going to ask what lives in the gulf between them, and we are going to find that the answer is almost nothing. We are going to ask what happens when 2 galaxies, 2 great clouds of grains, drift through each other, and we are going to find that, against all intuition, almost nothing happens to the grains themselves, because the gaps are so wide that even a head-on encounter passes through without contact. We are going to ask why, if there are hundreds of billions of stars above us, the night sky is dark, and we are going to find that the very emptiness we have been describing is part of the answer. We are going to feel, somewhere in the middle of the walk, what it is like to be one of those grains, 4 miles from any neighbor, with no bridge of matter you could walk across. And then, near the end, we are going to come back to the photograph, and we are going to look at it again, and we are going to see why the galaxy is bright precisely because it is empty, why the brightness and the emptiness are not opposing facts, but the same fact looked at from 2 angles, why the picture you started with was not wrong, only incomplete. Sit with that for a moment. The picture you started with was not wrong. The picture you started with was an honest map. It just did not have room, in its small flat frame, for the truth about distance. Distance does not photograph well. Distance has no light to contribute. Distance is what the camera cannot show, and the galaxy, more than anything else, is a structure made of distance. This is what tonight is for. It is a slow walk into what the photograph cannot say. It is a long, quiet sit with the emptiness that surrounds every burning point in the sky above you. It is a chance to feel, for a little while, the actual texture of the place you live in, which is not a crowded city of light, but a thin scatter of light across an ocean of vacuum that the eye, looking at the right photograph, will read as fire. Settle in. There is nowhere we need to be. We are going to start, in the next part, by walking from the grain on your table to the next grain, 4 miles away, and we are going to make that walk slowly, the way a real walk feels, the way an empty road feels at night, when the houses are dark and the street lights are far apart and the air is still. We are going to translate the numbers into something your body can hold. We are going to introduce the patient astronomers who measured those distances for us, one parallax angle at a time, across careers that began before the photograph existed and ended in a quieter understanding of how far the lights are from each other. And by the time we come back to where we started, by the time we return to the photograph in the final part of the walk, the photograph will look different. The arms will not look as dense. The core will not look as crowded. The whole image will feel, in some hard-to-name way, thinner, lighter, more translucent. Not because anything in the photograph has changed, but because you will have walked through the territory the photograph cannot show, and the territory will have lent its quietness back to the map. For now, hold the grain, picture it on the table in front of you. Notice how small it is. Notice how easy it would be to lose. Notice how much room there is around it, on the table, on the floor, in the room, in the house, in the street outside. Notice how much room there is. That room is the galaxy. The light is the rounding error. We will walk now. Let us go back to the grain on the table. It is sitting in front of you, small, pale, almost translucent if you held it up to the light. A single grain of fine sand, no bigger than the head of a pin, no heavier than a breath. And we have agreed, you and I, that this grain is the sun, the entire sun. The fusion core, the convection layers, the photosphere with its slow boiling surface, the corona reaching out for millions of miles into the dark, the magnetic field that bends solar wind around the planets, the 8 worlds in their long ellipses, the dwarf planets and the asteroid belts and the comet halo, all of it, every body that orbits this star, compressed down into a single mote on the surface of a kitchen table. The Earth is not even on the table. The Earth at this scale is too small to see. It would be smaller than the dust on the grain itself. It would be a fraction of a micron, a speck inside a speck. Your house, the city you live in, the continent you live on, the ocean beside it, the whole planet, all of it tucked into something smaller than the period at the end of a sentence, sitting within a handspan of the grain we are calling the sun. This is the scale we are using. I want you to take that in slowly, because the rest of the walk depends on you holding it. Now I want to ask the simplest possible question. Where is the next grain? Not metaphorically, literally. If we are using this scale, if the sun is a grain on your kitchen table, Where, in physical space, is the next grain? Where is the nearest other star rendered at the same compression? The nearest other star to our Sun is called Proxima Centauri. It is a small red dwarf, much smaller than the Sun, much dimmer, much cooler, but a star nonetheless, with its own fusion at its core and its own planets in their own quiet orbits, including a rocky world roughly the size of Earth that may or may not have liquid water on its surface, depending on how the atmosphere holds together. Proxima Centauri is, by every measurement we can make, our closest stellar neighbor. It is the next house on the street, the next light in the row. At our scale, Proxima Centauri is another grain of sand, just like the one in front of you, sitting about 4 miles away. 4 miles. Let that land for a second. I am not exaggerating. I am not stretching the metaphor for dramatic effect. The actual ratio of the size of the Sun to the distance from the Sun to Proxima Centauri, when you scale the Sun down to a grain of sand, places the next grain roughly 4 miles from where you are sitting. If you are in your bedroom, that grain is across town. If you are in an apartment in a city, that grain is in a different neighborhood. If you are in a quiet house in the countryside, that grain might be in another village entirely. You would have to put on shoes. You would have to go outside. You would have to walk for over an hour, or drive for 10 minutes, or take a bus, or follow the road as it curves around hills and past houses and through intersections. And somewhere at the end of that journey, on someone else's kitchen table, there would be another grain. And between the two grains, in the 4 miles of intervening space, there would be nothing. Not nothing in the loose sense, nothing in the strict sense. No second grain, no third grain, no scattered handful of dust waiting to be discovered halfway through the walk. No softer star hiding between the bigger ones. Just the road, and the houses, and the lawns, and the street lights, and the sky, and the long quiet space of 4 miles, with 2 grains on 2 tables at either end of it, and nothing between them that belongs to the model at all. Hold that for a moment. In the real galaxy, in the real distance between our Sun and Proxima Centauri, there is also almost nothing. A few atoms of hydrogen per cubic centimeter, some sparse dust, stray photons traveling through. Magnetic fields drifting without anything to push against. We will come back to what little is there in the next part, but for now, what matters is the gap, the 4 miles, the 2 grains, the geometry of the walk. 2 grains, 4 miles apart, nothing between. Small, distant, alone. That is your neighborhood. And here is where I have to ask you to do something a little harder, because Proxima Centauri is the nearest star, and the nearest star is almost always the easiest star to talk about. But the galaxy is not made of nearest stars. The galaxy is made of all the stars. So let me ask the next question. Where is the third grain? The third nearest star, the next one out after Proxima Centauri, is a system called Alpha Centauri AB, a pair of stars orbiting each other. At our scale, that pair sits roughly the same distance away as Proxima itself, give or take. They are essentially in the same direction, on the same patch of the model, the same general neighborhood. So move on. Where is the next system after that? The next star with its own light, its own gravity, its own quiet existence. Now you are looking at Barnard's star, a small red dwarf 6 light-years from the Sun. At our scale, Barnard's star is roughly 6 miles from your table. Then Wolf 359, 8 light-years out, about 8 miles, then Lalande, then Sirius, then Luton's star, all of them small, all of them sparse, all of them placed across distances that, in our compressed model, would carry you across counties. This is the part of the walk where the model starts to strain. Because if you keep going, if you keep placing grains one after another at their honest distances, you stop being able to hold the picture in any single room. You stop being able to hold it in any single town. The grains spread out across miles, and then across tens of miles, and then across hundreds of miles, and somewhere in that spreading the kitchen table model breaks down, because the kitchen table is not big enough to hold the galaxy, and your country is not big enough to hold the galaxy, and your continent is not big enough to hold the galaxy. At our scale, the Milky Way is many millions of miles wide. The model fails. The kitchen cannot contain it. The road cannot contain it. The world itself cannot contain it. I want to be honest about this, because I do not want the metaphor to lie to you the way the photograph did. The grain of sand model is useful at small scales. It lets you feel the distance between the Sun and Proxima. It lets you feel the distance between the Sun and a few of its nearest neighbors. But at the scale of the whole galaxy, the model breaks. The galaxy is bigger than the metaphor we have built for it. The galaxy is bigger than any metaphor we can build for it. That is one of the first true things about the galaxy. It is bigger than the metaphors. Let me say it again so it registers. The galaxy is bigger than the metaphors. The grain of sand, useful as it is only useful for the local block. To talk about the rest, we have to use the numbers themselves. And we have to be patient with the numbers, because the numbers are doing work the bodily metaphors cannot do. So let me give you the central number now. The average distance between two stars across most of the volume of the Milky Way disk is roughly 5 light years. 5 years for light to cross from one star to its average neighbor. 5 years of vacuum. 5 years of nothing in between. 5 light years. Think about what that means. Light, the fastest thing the universe permits, takes 5 years to travel between an average pair of stars. If you sent a signal from your grain to the next grain, the signal, moving at the maximum speed allowed by physics, would arrive 5 years after it left. If the other grain replied at the same instant the signal arrived, the reply, also moving at the maximum speed allowed by physics, would arrive back at your table 5 years after that. A round-trip conversation between two average grains would take a decade, and that is the average. That is the typical gap. Out in the thinner regions of the disk, the gaps are larger. Out toward the edge of the spiral arms, the gaps are larger still. In the halo of the galaxy, the gaps become enormous. The stars there are spread so thin that the word neighborhood begins to lose meaning, because a neighborhood implies a place where you might walk to the next house, and there is no walk that crosses these distances. There is no walk that could. Hold that for a moment. The average distance between any two stars in our galaxy is 5 light years. The galaxy contains hundreds of billions of stars, and almost all of the volume of the galaxy is the gap. The 5 light-year gap, repeated across hundreds of billions of pairs, in 3 dimensions, in every direction, layered on top of itself, stacked through the disk, extended through the halo. The galaxy is mostly the gap. The galaxy is mostly the 5 light years between any one grain and the next. The galaxy is mostly nothing. The galaxy is mostly distance. The galaxy is mostly the spaces between. Three ways of saying the same thing, because the thing being said is large enough to need three sayings. The galaxy is mostly nothing. The galaxy is mostly distance. The galaxy is mostly the spaces between. Each of these sentences points at the same truth from a slightly different angle. The first says it in terms of substance. What is there is not much. The second says it in terms of geometry. What is between is large. The third says it in terms of relation. What links the points is mostly vacancy. All three are accurate. None of them is enough on its own. This is the galaxy we live in. This is the architecture of the place. I want to pause here because I do not want to push past this without giving you the chance to feel it. You live inside a structure that is overwhelmingly empty. Not partially empty, not somewhat empty, overwhelmingly. The bright points are the rounding error. The bright points are the speck on the otherwise blank page. You are sitting on a planet orbiting one of those bright points, and that bright point is one grain among hundreds of billions. And between your grain and the next, there is enough emptiness to swallow every walk you have ever taken, every drive, every flight, every journey, and still have room left over for all the walks you will never take in any of the lifetimes you will never live. Sit with that for a moment. It is the kind of fact that needs sitting with. It is not the kind of fact that can be absorbed on the first hearing. It is the kind of fact that you have to come back to several times before it begins to settle into the body. Because the body, naturally, lives at the scale of streets and rooms and tables and grains. The body cannot feel 5 light years. The body cannot feel 400 billion grains. The body can only do what we are doing now, which is to take the small things it can hold and to use them as handles for the larger things it cannot. I want to tell you about a man named Friedrich Bessel, because Bessel is part of how we know any of this. In the early decades of the 19th century, Bessel was a German astronomer working at the observatory in Königsberg. He was a precise man, methodical, careful, the kind of person who would spend years on a single measurement if the measurement was worth getting right. And the measurement he chose was one of the oldest open questions in astronomy. How far away are the stars? For thousands of years, no one had been able to answer this question. The stars were obviously distant, far more distant than the sun or the moon, but how much more distant, by how many times, in what units, no one could say. The stars looked like points of light fixed to a great sphere, and the sphere was understood to be large, but the largeness had no measure attached to it. There was no scale, there was no number. There was only the night and the lights and the human guess. What Bessel did was patient and quiet and extraordinary. He picked a single star, a small star in the constellation Cygnus called 61 Cygni, and he measured its position in the sky with the most careful instruments his observatory could provide. Then he waited. He waited 6 months. During those 6 months, the Earth moved along its orbit, traveling from one side of the Sun to the other, covering a distance of nearly 200 million miles. And from this new position, Bessel measured the star again. Because the Earth had moved, the star appeared, very slightly, to have moved too. Not because the star itself had gone anywhere, but because the geometry of the line of sight had shifted. It is the same effect you can produce by holding your finger up at arm's length and closing one eye, then the other. Your finger appears to jump against the background. The stars do the same thing, except their jump is so small that for centuries no one could measure it. The angles involved are tiny, fractions of a fraction of a degree, less than the width of a human hair held at the distance of a city block. To measure something that small, you need instruments of extraordinary precision, and you need the patience to make the measurement, and remake it, until you trust what you see. Bessel made the measurement, and from the angle of that tiny apparent shift, using nothing more than geometry, he calculated, for the first time in human history, the actual distance to a star. 61 Cygni, he found, was roughly 10 light-years away. That number does not sound dramatic now. We have grown used to it. But in 1838, when he published the result, it was the first time a human being had ever attached a real measurement to the distance of a star outside our solar system. Bessel had given us the first rung of a ladder we are still climbing. Every star whose distance we know, every catalogue of stellar positions, every map of the galaxy, every photograph whose scale we can read, every estimate of the size of the Milky Way, everything we know about how far apart the grains are, traces back, in a slow chain of inheritance, to that one careful angle measured in Königsberg by a patient man at a telescope. He spent a career doing this, star after star, angle after angle, year after year. He did not see what we see. He did not have the photograph. He did not have the spiral arms rendered in false color, the Hubble images, the Gaia maps. He had a telescope and a notebook and a long, quiet life of looking up. And he gave us the first honest number for the gap between two grains. I tell you this because I want you to feel that the distances we are walking through tonight are not abstractions invented for the script. They are measurements earned slowly by people who spent their lives at instruments, asking the same question over and over until the answer came clear. The 5 light-years between average stars is not a guess. It is a number that comes from many, many careful angles, taken by many, many patient observers, refined over centuries into something we can now state in a single sentence, as if it had always been known. It had not always been known. It was found out by Bessel, and by those who came after Bessel, and by those who came after them, in a slow, accumulating ledger of small, careful measurements that the galaxy has been allowing us to make. Hold that for a moment. The galaxy lets us measure it. The light travels for 5 years, or 10 years, or 100 years, or 1,000 years, or 100,000 years, and arrives at our instruments, carrying within it the information of where it came from and how far it has traveled. And we, the small grain on the small planet, take the light apart and read its history out of it. And from that reading we draw the map. The galaxy is mostly empty, and the emptiness lets the light through, and the light lets us measure the emptiness. It is a kind of agreement. It is a kind of geometry that includes us. So when I tell you that the average star is 5 light-years from its neighbor, I am telling you a thing that took many lifetimes to learn. I am telling you a thing that we did not always know. I am telling you a thing that is, when you scale the sun to a grain on your table, about 4 miles to your nearest neighbor, and then 4 to 6 more miles to the one after that, and then 6 to 10 more miles to the one after that, and then more and more and more, fanning out across our model into distances no kitchen can contain. Small, distant, alone. That is what the grains are. Each of them small enough to lose between your fingers. Each of them distant enough that the next one is across town, across the county, across the state. Each of them alone, in the sense that none of them has a neighbor close enough to touch, to share matter with, to interfere with in any direct way. Each of them burning on its own, in the middle of its own quiet patch of vacuum, with the light of the next grain arriving 5 years late, and the light of the grain after that arriving 10 years late, and the light of the grain at the far edge of the disk arriving 100,000 years after it was emitted, by which time the emitting grain may have changed, may have brightened, may have dimmed, may have become something else entirely. This is what the galaxy is. This is the architecture under the photograph. This is what the long exposure cannot show you, because the long exposure shows you only the grains and not the gaps, only the lit and not the unlit, only the rare exception and not the rule. The rule is the gap. The rule is the 4 miles. The rule is the 5 light years. The rule is the long, quiet space between any one burning point and the next. You live inside that rule. You are sitting, right now, on a planet that orbits one of those burning points. Your sky is full of other burning points, and every one of them, every single one you can name and every one you cannot, is at least 4 miles away in our model, at least 5 light years away in reality, at least a journey no body could ever make in the time any body has to make journeys. The nearest of them is unreachable in any practical sense. The farthest of them is unreachable in even the most imaginative sense. And the rule, the gap, the quiet space, surrounds all of them, every one in every direction. This is the place we are walking through. In the next part, we will look more closely at what lives in the gap between 2 grains. Because while I said earlier that there is almost nothing between them, almost is doing a lot of work in that sentence. There is something between them. There is something thin and quiet and almost invisible threading through the vacuum, a kind of cold whisper of matter spread so thin it is barely there. We will look at what it is. We will compare it to the best emptiness our laboratories have ever made, and we will find, gently, that the gap is even emptier than we thought. For now, hold the grain, picture it on the table, picture the 4 miles between it and the next one. Picture the long, quiet road you would have to walk to get from one to the other, with nothing in between worth mentioning. Then picture that road repeated, in every direction, hundreds of billions of times, layered 3-dimensionally through a disk 100,000 light years across. That is your galaxy. It is mostly the road. It is mostly the walking. It is mostly the nothing in between. So let us walk into the gulf. 2 grains, 4 miles apart. We have set them on their tables. We know where they sit. We know how far from each other they are. And we have said, gently, that between them there is almost nothing. I want to spend this part of the walk on the word almost, because almost is where the strangeness lives. If you could shrink yourself down to the scale of the model, and walk from your grain to the next one, you would set out from the kitchen table and step out into the road. And the road would be empty, in the way roads sometimes are at 4 in the morning, when the street lights are dim and the houses are dark, and the only sound is your own footsteps on the pavement. You would walk for an hour. You would walk for 2. You would not pass anything. There would be no second grain in the road. There would be no scattered handful of dust waiting to be found halfway through. There would only be the long, quiet space and the cold air and the long, slow movement of you across the gap. That is the model. That is the picture we have built. But the real gulf, the real space between our Sun and Proxima Centauri, is not exactly empty. It is almost empty. And the almost is worth describing, because the almost is what tells you how strange the place really is. Let me give you the number first, and then we will walk through what the number means. In the diffuse interstellar medium of the Milky Way, in the kind of average gulf between 2 average stars, the gas is so thin that there is roughly 1 hydrogen atom per cubic centimeter. 1 atom. In a volume the size of the tip of your finger, that is the average. In some regions it is denser. In some regions it is much thinner. In the warmest and most diffuse regions, the density drops to 1/100th of that, or less. In the densest cold clouds where new stars are forming, the density can rise to thousands or even millions of atoms per cubic centimeter. But on average, across the long, quiet corridors between the grains, you find 1 atom of hydrogen in the space of a sugar cube. 1 atom, and then a long stretch of nothing, and then another atom, and then a long stretch of nothing, and then another. Let that land for a second. I want to give you a comparison so you can feel how thin this is. The air in the room you are sitting in right now contains, in every cubic centimeter, somewhere around 25 quintillion molecules. 25 followed by 18 zeros. In every sugar cube of air around you, in the small space between your nose and your hand, when you raise your hand to your face, in the volume of any breath you take in or let out. That is what the matter density of your room is, and the room feels empty to you. You can see across it. You can move through it without resistance. You can throw a ball through it. You can clap your hands and the air parts so easily you barely notice. That is dense. Now drop that number by a factor of 25 quintillion. Now reduce 25 followed by 18 zeros to a single solitary one. That is the matter density of the gulf between 2 stars. That is what the air would be if it were interstellar gas. There would not be enough of it to feel. There would not be enough of it to breathe. There would not be enough of it to call air at all. Hold that for a moment. The space between the grains is not the room you are sitting in with the matter taken out. The space between the grains is the room you are sitting in with almost all of the matter taken out, and then almost all of the rest taken out, and then almost all of the rest taken out, until you arrive at a kind of stillness so thin that the word room stops meaning anything. There is no medium there in any practical sense. There is no substance there in any practical sense. There is only the long, thin presence of a few stray atoms drifting through unfathomable volume, separated from each other by distances so large that an atom could go years, decades, lifetimes, without ever meeting another atom in any meaningful way. And it is mostly hydrogen, because the universe is mostly hydrogen. About 90% of those atoms, by number, are hydrogen. Most of the rest is helium. A trace amount, less than 1%, is heavier elements, carbon and oxygen and nitrogen and iron, and the rare other atoms cooked in the cores of older stars and exhaled into the interstellar medium when those stars died. So the gulf is not pure. There are flavors in it, but the flavors are thin. The flavors are spread across volumes so large that no instrument we have built can scoop up the gulf and study it directly. We have to read it by the way it shapes the light that travels through it. We have to read it by absorption. We have to read it by what it does to the photons of more distant stars on their way to our telescopes. Because there are also photons in the gulf. That is the other thing I want you to know. The gulf is full of light. Not full in the sense that you would see it. Full in the sense that every cubic centimeter of the space between the grains is being traversed at any given moment by photons from somewhere. Photons from the sun. Photons from Proxima. Photons from stars hundreds of light years away. Photons from the central bulge of the galaxy. Photons from other galaxies entirely, having traveled for millions or billions of years. Photons from the cosmic microwave background, the cold afterglow of the early universe, soaking through everything at a temperature just shy of absolute zero. The gulf is a kind of luminous traffic, light moving in every direction at once, intersecting at every point, never colliding with itself, never interfering with itself in any way that would slow it down or turn it aside. The light moves through, and the gas barely notices. The gas is so thin that the light passes almost unimpeded. The light moves through, and the dust, what little of it there is, barely notices either. There is dust in the gulf in some places. Tiny grains of silicates and carbon and ice, frozen and slow, drifting on currents you could not detect. The dust is sparse. The dust is rare. But the dust is there, and where it gathers in slightly thicker patches, it scatters and reddens the light that passes through it, which is one of the ways we measure how much of it there is and where. And the magnetic fields. I want to mention the magnetic fields because they are part of the texture of the place. The Milky Way has a magnetic field, not a strong one, not a field like the one around the Earth, which can deflect compass needles and trap charged particles into auroras. The galactic magnetic field is fantastically weak by terrestrial standards, weaker than the field in your refrigerator magnet by orders of magnitude, but it is there. It threads through the entire disk. It runs along the spiral arms. It loops and bends in slow patterns that take millions of years to evolve. And in the gulf between two grains, that field is present, drifting along with almost nothing to push against, because the gas is so thin that there are barely any charged particles for the field to act on. The field is just there, a pressure of geometry, a kind of organization in a place that otherwise has very little to organize. So when I said almost nothing, I meant it carefully. Let me restate what is between the two grains. A few atoms of hydrogen per cubic centimeter, with traces of helium and even fewer traces of heavier elements. Sparse cosmic dust, fine as smoke, drifting at temperatures close to absolute zero. Photons in every direction, traveling at the speed of light from every source in the visible universe. A weak magnetic field threading through the whole structure, and vast amounts of nothing in between any one of these things and the next. That is the gulf. That is what lives in the 4 miles between our two grains, scaled up to the real distance between our two stars. Almost nothing, but not quite nothing. A thin breath of matter. a weak signature of organization, a great deal of light passing through. I want to give you one more comparison, because I think it is the comparison that makes the strangeness most clear. In our laboratories on Earth, in the cleanest and most carefully prepared vacuum chambers we have ever built, where engineers have pumped out as much air as their pumps will allow, where the walls are cooled and the seals are perfect, and the residual gas is measured in molecules and not in volumes, the very best vacuum we have achieved still contains, in every cubic centimeter, somewhere between a few hundred and a few thousand molecules. That is the best vacuum we have ever made. That is the absolute frontier of what human engineering can produce in our most sophisticated facilities, with our most patient pumping and our most careful sealing. A few hundred molecules per cubic centimeter, a few thousand at worst. That is our high vacuum. The interstellar medium, on average, has 1 atom per cubic centimeter. 1. The empty space between two ordinary stars is emptier than the best vacuum any human being has ever engineered. We cannot make a vacuum that thin. We do not have the technology. We do not have the patience. We do not have the volume. The universe makes it for us, for free, by simply being large enough that the matter has nowhere to be. The vacuum of interstellar space is not something we have to construct. It is the default condition. The thing we have to construct on Earth, with our pumps and our chambers and our careful preparation, is a faint imitation of what the gulf between two grains already is. Sit with that for a moment. You live on a planet whose atmosphere is so thick that we measure its molecules in quintillions per cubic centimeter. Above the atmosphere, in the orbital regions where satellites fly, the density drops to something thinner, but still thicker than the gulf between the stars. Beyond the orbits of the planets, in the outer reaches of the solar system, the solar wind keeps the local space slightly denser than true interstellar gas, a kind of bubble of solar particles holding the harder vacuum at bay. And then, past the heliopause, past the boundary where the sun's wind meets the wind of the galaxy, you cross into the gulf. And on the other side of that crossing, the density of matter drops to a single atom per sugar cube and stays at that level, on average, for the next 4 miles in our model, the next 5 light years in reality, all the way to the next grain. That is the medium our light has to travel through to reach us. That is the field on which the stars are arranged. That is the substance of the galaxy, which is mostly the absence of substance. Let me say it 3 ways, because the saying is the only way through. It is the boundary of matter. It is what matter ends at when matter ends. Out beyond the corona of a star, the matter density falls and falls, and at some point falls into the gulf. And the gulf is what matter is not, mostly, in the spaces where it isn't. It is the field on which the stars are arranged. The galaxy is not a sheet of stars. The galaxy is a sheet of mostly nothing, with stars set into it like points of light marked on a vast, translucent membrane. The membrane is the gulf. The points are the grains. The structure of the galaxy is the membrane more than the points, because there is so much more membrane than there are points. It is the medium through which all light must travel before it reaches us. Every photon that arrives at our telescopes from any star outside our solar system has spent its entire journey moving through the gulf. The gulf is the path. The gulf is the corridor. The gulf is what the light has to cross to be seen. If the gulf were thicker, the light would be dimmed by it. If the gulf were denser, the light would be scattered by it. Because the gulf is so thin, the light arrives nearly untouched, carrying within it the information of its source across distances that no body could ever travel. The gulf is what makes the information possible. 3 sentences, the same fact, stated 3 ways. The boundary of matter, the field on which the stars are arranged, the medium through which all light must travel. All 3 are accurate. All 3 are insufficient on their own, but together they begin to give the gulf a shape in your mind. And here is the thing I want you to carry forward from this part of the walk. The gulf is not a failure. The gulf is not a lack. The gulf is not the absence of something that should be there. The gulf is the geometry that makes the rest of the galaxy possible. If the gulf were full, the galaxy would not be a galaxy. It would be a single hot, dense sphere of matter, or a slow cooling cloud of gas, or a structure too thick for light to travel through, or a place where stars could not exist as individual burning bodies because they would be merged or smothered or torn apart by their neighbors. The reason the stars can be stars, the reason the grains can be grains, the reason each one of them can burn for billions of years with its own quiet fusion at its core, is precisely because the gulf is around them, holding them apart, giving them room to be what they are. The emptiness is what allows the brightness. The distance is what allows the points. The nothing is what allows the something. This is not a paradox. This is the actual physics of the place. A star is a body that needs space around it to exist. A galaxy is a collection of stars that needs the gulfs between them to be a collection. The structure depends on the spacing. The arrangement depends on the gaps. If you took the gaps away, you would not get a denser galaxy. You would get no galaxy at all. You would get a different kind of object with different physics, in which stars in the form we know them could not happen. The galaxy is mostly nothing, and the mostly nothing is not the part we should regret. The mostly nothing is the part that makes the something possible. Every grain on the table is what it is because of the 4 miles around it. Every burning point in the sky is what it is because of the long, quiet vacuum that surrounds it. You cannot have the fire without the room for the fire to be. You cannot have the light without the dark for the light to travel through. Hold that for a moment. The gulf is the architecture. The points are the decorations. We talk about galaxies as if they are made of stars, but really, in the strictest accounting, they are made of the space between stars, with stars sprinkled into that space at very rare and very precious intervals. The space is the substance. The stars are the exceptions. I am thinking now about the people who have spent careers measuring the gulf, not the distances between the grains, which we talked about last part with Bessel and his patient angles, but the gulf itself, the gas, the dust, the fields, the faint thin medium between the stars. There is a discipline called radio astronomy that began in the middle of the 20th century when astronomers realized that the gas in the gulf, the diffuse atomic hydrogen drifting through interstellar space, was not silent. It was emitting very faintly, very steadily, a single tone at a wavelength of 21 centimeters, the result of a slow quantum flip in the spin of its electron. The signal is extraordinarily weak. Any one atom emits it only rarely, on timescales of millions of years. But the gulf is so vast, and contains so many atoms in aggregate that the combined signal of all of them adds up to a faint, steady, detectable hum that radio telescopes can hear. For decades, astronomers have been listening to that hum. They have built dishes and arrays and interferometers across the planet to gather it. They have mapped its distribution across the sky. They have traced the patterns of the gas through the spiral arms of the galaxy, watched it pool in the denser regions where new stars will eventually form, followed its slow drift through the disk and out into the halo. The map of the Milky Way that we have today, the model of how the gas is distributed, of where the gulfs are thinner and where they are thicker, comes from many, many careful nights of listening at 21 centimeters, and from many, many careful astronomers turning the data into shapes. I think about this when I think about the gulf. The gulf is not silent. The gulf is humming very softly at a single note that takes a great instrument to hear. The gulf is full of a thinness that nonetheless has voice. The almost nothing in the 4 miles between our grains is, when you listen carefully enough, telling us things about itself, where it is, how fast it is moving, what temperature it is, whether it is being stirred by some distant event or sitting still in the cold of the spaces between. And the listening has built the map. The map has built the picture. The picture has given us what we know about the structure of the gulf, which is most of the galaxy by volume, which means the listening has given us most of the galaxy. That is patience. That is the slow, patient work of figuring out a place that is mostly empty by paying very close attention to the very little that is there. So when you picture the road between your grain and the next grain, I want you to picture it now with a little more texture, not full, not anywhere close to full, still almost nothing, but not pure nothing either. A scatter of single atoms drifting through the dark. A few specks of fine dust at temperatures near absolute zero. A weak magnetic field threading through the corridor with almost no resistance. Photons moving through in every direction, carrying the light of distant grains across the vacuum. And, very faintly, a hum at 21 centimeters. The slow, patient sound of hydrogen being itself, emitted by the rare atoms that happen to be in the road at any given moment. That is the gulf, thin, cold, almost silent, almost still, mostly nothing, but not pure nothing, just enough to be there, just enough to be detectable, just enough to be the medium through which everything else has to travel. And around it, holding it, are the grains, the points of light, the stars, burning in their own quiet patches of the same gulf, separated from each other by the same thin distances, organized into the structure we call a galaxy, not despite the gulf, but because of it. In the next part of the walk, we are going to do something that should be dramatic and find that it is not. We are going to take 2 galaxies, 2 great clouds of grains, and we are going to push them through each other. We are going to collide them, and we are going to discover, walking through the math of it carefully, that what looks from outside like a catastrophic head-on impact is, from the inside, almost nothing. The grains will slide past each other. The stars will not touch. The structure will rearrange itself slowly over hundreds of millions of years. But the burning points themselves will continue burning, each one alone in its own gulf, the gulfs reorganizing around them, but the grains themselves untouched. This is the proof of the emptiness we have been describing. This is what happens when you take everything we have built so far and let two galaxies test it against each other. For now, picture the gulf one more time. Picture the road. Picture the long, quiet corridor of almost nothing between any two burning points in the sky above you. And picture that corridor everywhere, in every direction, around every star, between every grain. The galaxy is mostly that corridor. The galaxy is mostly the road between the lights. The galaxy is mostly the room around the fire, and the room is what lets the fire burn. Now let us test the emptiness. We have built a picture, slowly, across the first 3 parts of this walk. A grain of sand on a kitchen table, the next grain 4 miles away. The long, quiet road between them, thinner than any vacuum we can engineer, holding almost nothing but a few stray atoms and a weak field and the light passing through. We have said that the galaxy is mostly this road, mostly this gap, mostly the spaces between. And you have, I hope, begun to feel it, begun to carry the picture in your body. But a picture is only a picture until you test it. So let me give you the hardest test I can think of. Let me take 2 entire galaxies, 2 great clouds of grains, and let me run them straight into each other, and let us see whether the emptiness holds. Here is the situation, stated first in the way it is usually stated, the dramatic way, the way that makes for a striking headline. Our galaxy, the Milky Way, is not alone in space. It has a large neighbor. Across the gulf between galaxies, far larger than the gulf between any 2 stars, lies the Andromeda Galaxy, a great spiral much like our own, perhaps larger, containing as many as 1 trillion stars to our few 100 billion. Andromeda is the nearest large galaxy to us. It is about 2.5 million light-years away. On a clear, dark night, far from city lights, you can see it with your naked eye, a faint smudge in the constellation that bears its name, the most distant thing most human beings will ever see without a telescope. The light you see from it left 2.5 million years ago, before our species existed in its current form. You are looking at the deep past of a structure containing 1 trillion suns, and Andromeda is moving toward us. It is falling through the gulf between galaxies, pulled by the mutual gravity of the 2 great structures, approaching at something on the order of 100 kilometers per second, that is hundreds of thousands of miles per hour. 2 enormous spirals, each containing hundreds of billions of stars, each spanning 100,000 light-years or more, rushing toward each other across the dark at a speed that, in human terms, is almost incomprehensible, and in roughly 4 to 5 billion years, give or take, depending on the exact measurements of Andromeda's sideways motion, which are still being refined, the 2 galaxies are expected to meet. That is the dramatic version. 2 titans on a collision course, hundreds of billions of stars against 1 trillion, a head-on encounter at hundreds of thousands of miles per hour, the end of the Milky Way as we know it. A cosmic catastrophe building slowly across billions of years, and we are inside one of the 2 galaxies, riding it toward the impact. Let that land for a second. It sounds like the end of everything. It sounds like a crash beyond all crashes, a smashing together of 2 of the largest structures the universe contains, an event so violent that the imagination recoils from it. two galaxies, a trillion stars and several 100 billion more, colliding. And now, let me take the drama apart. Because the word colliding is doing something dishonest there, the same thing the photograph did in the first part of our walk. It is taking a structure that is mostly empty and describing it as if it was solid. It is taking two clouds of grains and describing them as if they were two cannonballs. And the truth, when you walk through it carefully, is so much stranger and so much quieter than the headline. Let us do the arithmetic of the encounter, gently, together. When the Milky Way and Andromeda meet, the two galaxies will indeed pass into and through each other. The disks will overlap. The spiral arms will interpenetrate. From a great distance, from outside, it will look like a merging, a tangling, a slow, violent embrace of two great pinwheels of light. The structure will distort. The arms will be pulled out into long streaming tails by the tidal forces of the encounter. Over hundreds of millions of years, the two galaxies will swing past each other, fall back, swing through again, and eventually settle into a single combined structure, a great elliptical galaxy that astronomers have already half-jokingly named, combining the two names into one. The Milky Way and Andromeda will become a single galaxy. That much is, in the long run, expected. But now ask the question that matters for our walk. When the two galaxies pass through each other, how many stars will actually collide? How many grains will actually strike other grains? How many of the hundreds of billions of burning points in one galaxy will run directly into the hundreds of billions of burning points in the other? The answer, when you work it out, is essentially none. Let me say that again so it registers. When two galaxies containing, between them, well over 1 trillion stars pass directly through each other in a head-on encounter, the number of stars expected to physically collide is, to the best of our calculation, approximately 0. Hold that for a moment. How can that be? How can two structures, each containing hundreds of billions of stars, pass directly through each other and have none of those stars hit? The answer is the emptiness. The answer is everything we have built across this walk. The answer is the 4 miles between the grains. Think back to the model. Our sun is a grain of sand. The next grain is 4 miles away. Now imagine 2 such arrangements, 2 vast clouds of grains, each grain 4 miles from its nearest neighbor, and imagine pushing one cloud through the other. Imagine the grains of one cloud drifting into the spaces of the other. What are the chances that any single grain from the first cloud, moving through the second, will happen to strike a grain in the second, given that each grain in the second cloud is 4 miles from any other grain, given that the grains are pinpricks, given that the space between them is enormous and nearly entirely empty? The chances are almost nothing. The grains are too small and too far apart. A grain of sand drifting across a city full of other grains of sand, each 4 miles from the next, will almost certainly pass through the entire city without touching a single one. It will glide through the gaps. It will slide through the gulfs. It will move through the spaces between, because the spaces between are nearly all there is. This is what will happen when the Milky Way and Andromeda meet. The 2 clouds of grains will drift into each other. Each grain will move through the gulfs of the other galaxy, finding, almost everywhere it goes, nothing but empty space. The stars of the Milky Way will pass between the stars of Andromeda. the way two handfuls of pollen thrown into the air pass through each other, the individual motes sliding past one another in the open air without colliding, the two clouds interpenetrating and mingling, and yet, at the level of the individual mote, touching almost nothing. Two clouds of pollen thrown together, passing through. That is the collision. That is the catastrophe. That is the head-on impact of two galaxies. At the level of the individual star, it is not an impact at all. It is a drifting through. It is a passing between. It is two sparse clouds of grains interpenetrating across hundreds of millions of years, each grain moving through the gulfs of the other, each one finding, almost everywhere, the emptiness we have been describing, the 4 miles, the 5 light years, the long, quiet road with nothing in it. Sit with that for a moment. The most violent event our galaxy will ever undergo, the collision with Andromeda, the merging of two great spirals into one, will involve, for the stars themselves, almost no violence at all. Your descendants, if any of them are still around in 4 billion years, if anything recognizable as life is still riding the grain we call the sun, will not experience the collision as a crash. They will experience it, if they experience it, as anything, as a slow and spectacular change in the night sky. Over millions of years, Andromeda will grow larger overhead, filling more and more of the heavens, its spiral arms unwinding across the sky. New regions of light will appear as the gas clouds of the two galaxies meet, but the sun will not strike another star. The Earth, if it still exists, will not be smashed by an incoming sun. The grains will slide past each other, each one still alone, each one still burning, each one still surrounded by its own quiet gulf of almost nothing. I want to be careful and honest here, the way I have tried to be honest throughout this walk, because there is a real subtlety in the recent science that I do not want to paper over. For a long time, beginning especially with careful measurements made using the Hubble Space Telescope a little over a decade ago, the collision was treated as a near certainty. Astronomers had measured not just Andromeda's motion toward us, which is relatively easy to detect, but its sideways motion across our line of sight, which is fantastically difficult to measure, and which determines whether the two galaxies will strike head-on or merely graze past each other. The Hubble measurements suggested the sideways motion was small, which meant a direct encounter, which meant a merger in roughly 4 billion years. That became the standard story. That is the story you may have heard. But science is a patient and self-correcting thing, and more recent work has complicated the picture. Newer measurements, drawing on data from the Gaia spacecraft, which has mapped the positions and motions of more than 1 billion stars with extraordinary precision, have been folded into large sets of simulations. Researchers ran the encounter not once, but tens of thousands of times, varying the uncertain quantities within their measured ranges, accounting for the gravitational influence of other nearby galaxies like the Large Magellanic Cloud and the Triangulum Galaxy. And what they found was that the collision is not as certain as it once seemed. In a substantial fraction of the simulations, the two galaxies pass each other at a distance and do not merge for a very long time, if at all. The probability of a direct collision within the next 5 billion years in this newer work dropped considerably from the near certainty of the older picture. So the honest statement, the one I want to give you, is this. The Milky Way and Andromeda are approaching each other. They may merge in 4 to 5 billion years. They may merge much later. They may, in some scenarios, not merge for a very long time at all. The exact future depends on measurements we are still refining, and the picture has shifted as our instruments have improved, and it may shift again. But none of that uncertainty touches the point I am making. Whether the galaxies merge in 4 billion years or 10 billion years or pass each other by, whenever and however two galaxies do pass through one another, and many of them have, across the long history of the universe, and many of them will, the stars within them do not collide. That much is not in doubt. That much falls directly out of the emptiness. The grains are too small and too far apart. The gulfs are too wide. The pollen passes through the pollen. The factual tension in the recent science, the question of whether and when our particular collision happens, is itself part of the story, a reminder that we are still measuring, still refining, still patiently improving our picture of the place we live. But the deeper truth, underneath the tension, the truth about what happens to the stars when galaxies meet, is settled, and it is settled by the emptiness. Let me say it plainly. When galaxies collide, the stars do not. This is the central proof of everything we have been walking through. If the galaxy were as full as the photograph suggests, if the stars were as crowded as the long exposure makes them look, then two galaxies passing through each other would be a catastrophe of impacts, a shattering of suns against suns, a chaos of collisions. But the galaxy is not full. The galaxy is mostly empty. And so two galaxies can pass directly through one another, and the stars within them, the grains, the burning points, will almost all survive the encounter untouched, sliding through the gulfs of the other galaxy, each one still alone. The collision that is not a collision, the crash in which nothing crashes, the impact in which almost nothing hits. Hold that for a moment. Now, I do not want to leave you with the impression that nothing happens at all. Something does happen. It is just not what the word collision leads you to expect. Two things change when galaxies meet, and both of them are worth understanding, because they show you what the galaxy is actually made of when you test it. The first thing that changes is the structure. Gravity does not require contact. The stars do not need to touch in order to feel each other. As the two galaxies pass through each other, the gravity of each pulls on the stars of the other, and over hundreds of millions of years, this gravitational interaction rearranges the architecture of both. The neat spiral disks are pulled apart. The arms are stretched into long streaming tails. Stars are flung into new orbits, some of them hurled far out into the halo, some of them pulled inward toward the center. Our own sun, if it is part of a merger, will likely be thrown into a different orbit, farther from the galactic center than it is now. The shapes of the galaxies dissolve and reform. The two spirals, over billions of years, settle into a single, rounded, elliptical structure, the orderly disks replaced by a great swarm of stars on randomized orbits. This is real change. This is dramatic change. But notice what is doing the changing. It is gravity acting across the gulfs, rearranging where the grains are without any grain ever touching another. The structure transforms while the components remain individually untouched. The architecture is rebuilt while the bricks slide past each other without contact. It is a reshaping carried out entirely through the long reach of gravity across empty space, which is, after all, the only thing the galaxy has ever used to organize itself. The second thing that changes is the gas. And here, finally, is where there is something like a real collision, but not between stars. Remember the gulf. Remember the thin medium between the grains, the hydrogen, the dust, the cold, drifting gas. Each galaxy carries enormous reserves of this gas, spread thin across its disk. And while the stars are too small and too far apart to collide, the gas clouds are large. They are diffuse, but they span enormous volumes. And when the gas of one galaxy meets the gas of the other, the clouds cannot simply pass through each other the way the stars do. They are too extended. They overlap. They compress. They shock against each other. And where gas is compressed, gas collapses. And where gas collapses, new stars are born. So the meeting of two galaxies, which involves almost no collisions between existing stars, triggers a burst of the creation of new ones. The disrupted gas, shocked and compressed by the encounter, collapses into vast regions of star formation. The merging galaxies light up with the birth of new suns. The sky, for whatever observers might be present, blazes with newly forming stars and the glowing clouds around them. The collision that destroys almost nothing nonetheless creates a great deal. The grains do not break, but new grains are kindled out of the gulf, out of the thin medium between, out of the very emptiness we have been describing, compressed at last to the point where it can light. Sit with that for a moment. The most violent thing two galaxies can do to each other does not kill their stars. It rearranges them gently, across hundreds of millions of years, through the patient reach of gravity, and it gives birth to new stars out of the compressed gas of the gulfs. The collision is not a destruction, it is a transformation and a creation. It is two clouds of pollen drifting through each other, and in the drifting, some of the dust between the motes catches fire and becomes new motes. Nothing that was burning stops burning. New things begin to burn, and the whole structure slowly becomes something new. This is what the emptiness makes possible. This is the gift of the 4 miles, the 5 light years, the long quiet road between the grains. Because the stars are so far apart, they can survive the collision of their entire galaxies. Because they can survive, the structure can transform without catastrophe. Because the gas can be compressed without the stars being destroyed, new life can be kindled out of the encounter. The emptiness is not a danger here. The emptiness is a kind of safety. It is what allows two galaxies to meet and merge and still, at the level of the individual burning point, come through. I think about the people who worked this out, who took the dramatic headline of colliding galaxies and walked patiently through the arithmetic until they reached the quiet truth underneath. The teams who modeled the encounter on computers, simulating the motions of hundreds of billions of stars under their mutual gravity, watching the spirals distort and the tails stream out and the structure settle, frame by frame, across simulated billions of years. The astronomers who measured Andromeda's motion across the sky, repeating their observations over years to extract a sideways drift so small it had eluded measurement for over a century. The newer teams who folded in the Gaia data and ran the encounter tens of thousands of times to map the range of possible futures. This is patient work. This is careful work. This is the slow accumulation of understanding that lets us say with confidence that when galaxies collide, the stars do not. They did not see the collision. None of us will ever see it. It is 4 billion years away, or more, or it may not happen at all in the form we once expected. But they walked the arithmetic, and the arithmetic told them what the emptiness would do, and the emptiness, when you trust it, tells you that the grains slide past each other untouched. So here is where we have arrived. We have taken the emptiness we built across the first 3 parts of the walk, and we have tested it against the most violent event we could imagine, and the emptiness has held. 2 galaxies can pass directly through each other, and the stars within them do not collide. The 4 miles between the grains is enough. The 5 light years is enough. The long, quiet road is enough to carry a star safely through the entire body of another galaxy without ever striking another sun. The galaxy is mostly empty, and the proof is the collision that is not a collision. In the next part of the walk, we are going to turn the question around. We have spent these first parts looking down into the gulfs, into the spaces between the grains. Now we are going to look up. We are going to ask a question that sounds simple and turns out to be one of the deepest questions in all of astronomy. If the sky is full of stars, if there are hundreds of billions of them in our galaxy alone and billions of galaxies beyond, why is the night sky dark? Why, when you look up at night, do you see mostly black with scattered points of light instead of a sky blazing white from edge to edge? The answer, it turns out, has everything to do with the emptiness we have been walking through. For now, hold the picture. 2 clouds of grains drifting through each other. The stars sliding past, each one still alone, each one still burning. The structure slowly transforming. New stars kindling out of the compressed gulfs. And through all of it, the emptiness holding, the 4 miles holding, the long, quiet road carrying each grain safely through. The galaxies meet, the stars do not. That is what it means to be mostly empty. Now look up. We have spent 4 parts of this walk looking down and across, down into the gulfs between the grains, across the 4 miles between one star and the next, through the thin medium of the interstellar road. We have tested the emptiness against a collision of galaxies and found that it holds. Now, I want you to lift your eyes in your imagination and look up at the night sky, and I want to ask you a question that sounds so simple a child could ask it, and that turns out to be one of the deepest questions anyone has ever asked about the universe. Why is the night sky dark? Wait, before you answer, before you say what everyone says, which is that the night sky is dark because the sun has gone down, which is true and also completely beside the point. Let me sharpen the question until it becomes the real one. The universe is full of stars. We have established this. Hundreds of billions of stars in our galaxy alone, and our galaxy is one of perhaps 2 trillion galaxies in the observable universe, each one containing its own hundreds of billions or trillions of stars. The number of stars in the universe is so large that there is no honest way to feel it. Numbers like that stop being quantities and become a kind of fog. But the point is this: there are stars in every direction. There is no direction you can look, no patch of sky you can choose that does not have stars in it, somewhere, near or far, close or unimaginably distant. So here is the real question. If there are stars in every direction, If every line you could draw outward from your eye eventually reaches a star, then why, when you look up, do you see mostly darkness? Why is the sky between the visible stars black? Why does every line of sight not end on the burning surface of some star, near or far, so that the entire sky, in every direction, blazes with the brightness of a stellar surface, edge to edge, with no dark spaces anywhere at all? Let that land for a second. Think about it carefully, because the logic is sharper than it first appears. Imagine you are standing in an infinitely large forest. The trees are scattered around you, near and far. Look in any direction, along any line. If the forest is large enough, that line, sooner or later, will strike a tree trunk. Not the nearest tree, perhaps, maybe a tree far in the distance. But somewhere along that line, eventually, there is a trunk. And the same is true for every other line you could draw. Every direction you look, your gaze eventually lands on wood. And so the forest, seen from inside, presents a solid wall of trees in every direction. You cannot see out. You cannot see gaps. The distant trunks fill in the spaces between the near ones, and the still more distant trunks fill in the spaces between those, until there is no gap left anywhere, and the whole circle of your vision is trunk, 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 an unbroken wall. Now replace the trees with stars, a universe filled in every direction endlessly with stars. Every line of sight drawn outward from your eye should eventually strike the surface of some star. The near stars leave gaps between them, yes, but the more distant stars fill in those gaps, and the still more distant stars fill in the gaps between those. And if the universe is infinite and full of stars, then there should be no gap anywhere, no direction you could look that does not eventually land on a stellar surface. And so the entire night sky, by this logic, should blaze. Not scattered points of light on a black background, a solid sheet of brightness, edge to edge, every part of the sky as bright as the surface of a star, the whole heavens on fire. But that is not what we see. What we see is mostly darkness, with scattered points of light set into it. What we see is a sky that is overwhelmingly black, with stars sprinkled across it like rare grains on a dark cloth. The sky is not a wall of fire. The sky is a dark field with occasional lights. And the logic I just walked you through says it should not be. The logic says, if the universe is full of stars, the sky should be full of light. This contradiction has a name. It is called Olbers' paradox, after a German astronomer and physician named Heinrich Wilhelm Olbers, who described it clearly in the early 19th century. But Olbers was not the first to circle the question, and I want to honor the others, because the question is old, and it was asked by patient minds across centuries before it found its answer. The puzzle reaches back at least to Thomas Diggers, an Englishman in the 16th century who imagined an infinite universe filled with stars and bumped up against the strangeness of the dark. It was considered by Johannes Kepler in the early 17th century, who looked at the darkness of the night sky and drew from it a conclusion that the universe could not be infinite and filled with stars, because if it were, the sky would not be dark. Kepler used the darkness as evidence. He read the black sky as a message about the size of the universe. It was circled again by others across the following centuries, by Edmund Halley, by Jean-Philippe de Chezeaux, and then by Olbers, whose name finally stuck to it, and later still it was thought through more deeply by writers and scientists who began, at last, to assemble the real answer. I want to pause on what these people were doing, because it is one of the most beautiful things in the history of human thought. They were looking at the dark, just the dark, the ordinary, nightly, unremarkable dark that everyone has always seen and almost no one has ever questioned. And they were asking, why? Why this particular dark? Why not light? What does the darkness mean? What is the black sky trying to tell us about the universe we live in? Hold that for a moment. The darkness of the night sky is not nothing. The darkness is a fact, and facts have causes. And the cause of this particular fact turns out to be deep. The black between the stars is not empty of meaning. It is one of the most informative things you can see. It is, when you understand it, a message about the age of the universe, about the speed of light, about the expansion of space, and about the very emptiness we have been walking through. The dark sky is a kind of evidence, hanging over your head every clear night, free for anyone to read, if they know how to ask the question. So let us read it. Let us walk patiently through why the sky is dark. There are several reasons, and they work together, and I want to give you each of them in turn, because each one is part of the answer, and the answer is richer than any single piece. The first reason is that the universe is not infinitely old. It had a beginning. As far as we can measure, the universe began roughly 14 billion years ago, and this single fact changes everything about the forest argument. Because light travels at a finite speed. Fast, almost unimaginably fast, but finite. And that means that when you look out into space, you are also looking back into time. The farther away something is, the longer its light has taken to reach you, and the further into the past you are seeing. When you look at a star 100 light years away, you see it as it was 100 years ago. When you look at a galaxy 1 billion light years away, you see it as it was 1 billion years ago. And here is the consequence. Because the universe is only about 14 billion years old, you can only see things whose light has had time to reach you within that span. There is a horizon, there is a limit. Beyond a certain distance, the light simply has not had time to arrive yet, because there have not been enough billions of years since the beginning for it to make the journey. The forest, it turns out, is not infinite from your point of view. The forest has an edge, not because the trees stop, but because beyond a certain distance, the light of the trees has not reached you yet. Your line of sight does eventually run out. It runs out at the edge of the observable universe, the distance beyond which light has not had time to travel since the universe began. So the first reason the sky is dark is that the universe is young enough and light is slow enough that we cannot see far enough for every line of sight to end on a star. Many lines of sight drawn outward from your eye simply run off the edge of the observable universe into regions whose light has not arrived, and those lines come back dark. The second reason works alongside the first. The universe is expanding. Space itself is stretching, carrying the galaxies apart from one another, and this stretching does something to the light that travels across it. As light moves through expanding space, its wavelength is stretched along with the space it crosses. Light that began as visible light your eye could see, is stretched over billions of years and billions of light years into longer and longer wavelengths, into the infrared and then into the microwave, until it falls entirely outside the range your eye can detect. The most distant light in the universe, the oldest light there is, the afterglow of the early universe itself, has been stretched so far by the expansion of space that it now arrives as microwaves, invisible to the eye, detectable only by special instruments. So even the light that does reach us from the most distant regions does not arrive as visible brightness. It arrives stretched, dimmed, shifted out of the range your eye was built to see. The far reaches of the universe are not dark because there is nothing there. They are dark to your eye because the light from them has been stretched into invisibility by the expansion of the space it had to cross. These two reasons together, the finite age of the universe and the expansion of space, are the deep cosmological answer to Olber's paradox. The sky is dark because the universe had a beginning, because light is finite, because we can only see so far, and because the light from beyond a certain distance has been stretched out of sight. This is the answer the textbooks give, and it is correct, and it is profound. The darkness of the night sky is evidence that the universe began. Kepler was reaching toward this when he read the dark sky as a message about the size of the universe. He was right that the darkness meant something. He just did not yet have the full shape of what it meant. But there is a third reason, and it is the reason that matters most for our walk. The reason that ties the dark sky back to the grain of sand on your kitchen table, and I want to give it to you with care. The third reason the sky is dark is the emptiness. The stars are sparse. Even setting aside the age of the universe, even setting aside the expansion of space, even within our own galaxy, even within the local neighborhood of grains, the stars are so far apart, the gulfs between them are so vast that their light does not fill the sky between them. Go back to the model. The sun is a grain of sand. The next grain is 4 miles away. The grain after that is 6 miles, 8 miles, 10 miles away. They are pinpricks, scattered across enormous distances, with nearly empty road between every one of them. Now, ask yourself, if you scatter a handful of grains of sand across a landscape, each one 4 miles from the next, will the grains fill your vision? Will they paint the air between them? Will they merge, at a distance, into a solid wall of sand? They will not. They are far too small and far too far apart. You would see, at most, a few scattered specks with enormous reaches of empty air between them. No matter how many grains you scattered, as long as each one stayed 4 miles from its neighbors, they would never fill the space between. They would never become a wall. They would remain what they are, scattered points in a vast emptiness, the emptiness overwhelming the points by an unfathomable margin. This is why the sky is dark. Let me say it again, so it registers. The sky is dark because the stars are scattered grains of sand, 4 miles apart in our model, 5 light years apart in reality, and scattered grains, no matter how numerous, do not paint the air between them. The points stay points, the gulfs stay gulfs. The emptiness we have been walking through, the emptiness that lets galaxies pass through each other untouched, is the same emptiness that lets the sky stay dark. The stars are too sparse to fill the heavens. There is too much road and too few grains. The dark between the stars is the same dark as the road between the grains. It is the gulf seen from inside, looking out. Hold that for a moment. The darkness you see when you look up at night is the emptiness of the galaxy made visible. It is the 4 miles between the grains, rendered as black sky. It is the long, quiet road between one star and the next, seen end on, stretching away from your eye into the dark. Every patch of black between 2 visible stars is a line of sight running out through the gulfs, past the near grains, between them, into the spaces where, near enough to be bright, there happens to be no grain at all. The dark is not the absence of stars in the universe. The dark is the presence of emptiness between them. The dark is what the gulf looks like when you stare straight down its length. And so we arrive at the both, and the move we have made before and will make again, because it is the truest shape this material has. The sky is full of stars, and the sky is dark. Both are true. These 2 facts are not in conflict. They are not even in tension once you understand them. The sky is full of stars in the sense that there are stars in every direction, near and far, more than any mind can hold. And the sky is dark in the sense that those stars are scattered grains across vast gulfs, too sparse to fill the heavens, their light unable to paint the emptiness between them, with the most distant light stretched out of sight, and the very farthest regions beyond the reach of light at all. The fullness and the darkness are the same situation described from 2 angles. A universe packed with stars that are nonetheless so far apart, so finite in their reach, so scattered across such emptiness that the overwhelming impression, looking up, is of dark. The sky is full of stars, the sky is dark, both are true. Sit with that for a moment. I find this one of the most quietly moving facts in all of astronomy, and I want to tell you why. Because the darkness of the night sky is something everyone has seen. Every human being who has ever lived has looked up at night and seen the dark with its scattered lights. It is one of the most universal experiences our species has. And for almost all of that history, no one knew that the darkness was telling them something. They saw it as simply the way things are, the neutral background, the empty stage on which the stars perform. They did not know that the darkness itself was a message, that the black between the stars was evidence of the age of the universe, of the finitude of light, of the expansion of space, and of the vast emptiness in which the stars are set. You know it now. The next time you stand under a dark sky, far from the lights of cities, and you look up at the scattered stars on their field of black, you can know that the black is not nothing. The black is the gulf. The black is the emptiness we have been walking through, seen from the inside, looking out along the road. The black is the 4 miles between the grains, repeated in every direction, stretching away from your eye into the depths of a universe too young and too sparse and too expansive for the light to ever fill. The darkness is the emptiness, made visible, hanging over your head, every clear night, free to read. And the stars are the rare bright grains, scattered across it, each one burning alone in its own patch of the dark, 4 miles from its nearest neighbor, 5 light years across the gulf, sending its light to you across years and centuries and millennia, arriving at last at your upturned eye, a single point of brightness in an overwhelming field of black. The sky is full of stars. The sky is dark. Both are true. In the next part of the walk, we are going to step into the dark itself. We have looked down into the gulfs and across the 4 miles and up into the black sky. Now, I want us to feel, for a little while, what it is to be one of those grains. What it is to burn alone in your own patch of the dark, with your nearest neighbor 4 miles away across a road no body could walk, with the light of every other grain arriving years late, with no bridge of matter you could ever cross to reach another star. This is the part of the walk where the emptiness stops being a fact about the galaxy and becomes a fact about you. It is the quiet, low place in the middle of the journey, and I will be honest with you when we get there, but I will also stay beside you. We are walking this together, and we are not in any hurry, and there is nowhere we need to be. For now, look up one more time in your mind at the dark sky and its scattered lights, and know that the dark is the gulf, and the gulf is the galaxy, and the galaxy is mostly the dark, with grains of light set into it, far apart, alone, burning. The dark is not empty of meaning. The dark is the emptiness, telling you the truth. Now, I want you to be the grain. We have looked at the grain from outside for 5 parts of this walk. We have set it on the table. We have measured the 4 miles to the next one. We have walked the road between them and found it nearly empty. We have watched 2 galaxies full of grains pass through each other without touching. We have looked up at the dark sky and understood it as the gulf seen from inside. But always, until now, we have been looking at the grains from the outside, the way you look at a model on a table, the way you look at a photograph on a wall. Now I want you to stand inside one. I want you to be the grain. I want you to feel for a little while what it is to be a star. You are a sun. You are a body of fire holding yourself together against your own gravity, burning at your core, pouring light out into the dark in every direction, steadily, patiently, for billions of years. Around you, perhaps, a few planets turn in their long, slow orbits, and on one of them, perhaps, there is something that looks up. But set the planets aside for a moment. Just be the star. Just be the grain, burning alone in its patch of the dark. Look around you. In every direction, the gulf, the thin, cold road, stretching away from you on all sides. And out there, 4 miles away in our model, 5 light years away in the truth, the nearest other grain, the nearest other star, your closest neighbor in all the universe, the single nearest burning point to your own. 4 miles, 5 light years. That is as close as your nearest neighbor gets. And here is what I want you to feel about that distance. It is not just far, it is uncrossable. Let me walk you through why, slowly, because the uncrossability is the heart of this part of the walk. Between you and your nearest neighbor, there is no wind. Wind requires air, and there is no air in the gulf. Only the few stray atoms per cubic centimeter that we walked through earlier, far too thin to be a wind, far too sparse to carry anything, far too empty to push against. The space between you and your neighbor is not a medium you could move through the way a swimmer moves through water or a bird moves through air. It is very nearly the absence of any medium at all. There is nothing to swim in. There is nothing to fly through. There is nothing there to carry you across. Between you and your nearest neighbor, there is no sound. Sound requires a medium too, something to vibrate, something to carry the wave from one place to the next, and the gulf has nothing to vibrate. If your neighbor could somehow cry out, the cry would have nothing to travel through. There is no sound that could cross the gulf between 2 stars. The silence is not a quiet. It is a structural impossibility of sound. The space itself cannot carry a voice. Let that land for a second. Between you and your nearest neighbor, there is no bridge of matter you could walk along. There is no path. There is no road in the sense of a thing you could set out upon and follow. The road we have been calling it is empty in a way that no earthly road is ever empty. An empty road on earth is still a road, still solid, still a surface you could walk. The road between two stars is not a surface. It is a gulf of vacuum, and there is nothing to walk on, nothing to push against, nothing to carry you, nothing to mark the way. If you wanted to cross from your grain to the next, there would be no ground beneath your steps. There would be only the falling through emptiness. For 4 miles in the model, for 5 light years in the truth, for a journey so long that light itself, the fastest thing the universe permits, takes 5 years to make it. So the neighbor exists. This is the strange and quiet heart of it. The neighbor is real. The neighbor is there, 4 miles away, 5 light years across the gulf, burning just as you burn, pouring out its own light into the same dark. You can see the neighbor. The neighbor's light reaches you, arriving 5 years after it left, a steady point of brightness in your sky. You know the neighbor is there. You have measured the distance. You have read the light. The neighbor is not a rumor. The neighbor is not a maybe. The neighbor is a fact, a definite, knowable, measurable fact. And the neighbor is unreachable. Hold that for a moment. This is what I want to call the situation of the unreachable neighbor. It is the defining geometry of being a star. You are not alone in the sense that there is no one else. There are hundreds of billions of others scattered across the disk, burning in their own patches of the dark. You can see many of them. You know they are there. But every one of them, including the very nearest, is across a gulf you could never cross, separated from you by a distance that no body could traverse in any span of time that means anything, connected to you only by the thin thread of light that travels between you, arriving years or centuries or millennia after it set out. The neighbor exists. The neighbor is unreachable. Both are true. Now let me make it more intimate still. Let me put an observer on the planet of your nearest neighbor. Imagine that around that nearest grain, that closest star, there turns a small world. And imagine that on that world, there is something that looks up, something that, on its own clear nights, gazes into its own dark sky and sees scattered points of light. And imagine that one of those points, one of the brightest in its sky, is you, is your star, is the grain you are standing inside. The observer on that distant world looks up and sees your light, arriving across the same 5 light years, 5 years late, a single steady point in their darkness, and they wonder, perhaps, as you wonder whether anything looks back. Something does look back. You look back. The two of you across the gulf are looking at each other, each seeing the other's light 5 years delayed, each wondering about the other, each set into the same dark, each burning, each real, and you will never meet. This is not a tragedy. I want to be careful here, because it would be easy to make it a tragedy, and it is not one. It is a situation. It is the architecture of the place. The two observers, you and the one on the distant world, are real, and you can each see the other, and the geometry of the galaxy ensures, with near certainty, that you will never cross the gulf to one another. not because of any failing, not because of any fault, not because either of you did anything wrong or failed to try hard enough, but simply because the distance is what it is, and the gulf is what it is, and the speed of light is what it is, and the spans of time available to living things are what they are. The numbers do not allow the meeting. The geometry forbids it, gently, without malice, as a simple consequence of how far apart the grains are set. Sit with that for a moment. The nearest neighbor, the closest other light in all the dark, is close enough to see and far enough to be forever beyond reach. And that is the best case. That is the nearest one. Every other grain in the galaxy is farther. Every other star is more distant, more delayed, more unreachable still. The light of the far edge of the disk arrives 100,000 years late, from grains that may have changed beyond recognition or ceased to burn entirely in the time it took their light to cross to you. You are looking, always, at a past you cannot reach, at neighbors you cannot touch, at a sky full of others, every one of whom is across a gulf no body could ever cross. This is the geometry of being a star. This is what the emptiness means when you stand inside it rather than looking at it from across the room. The emptiness that lets galaxies pass through each other untouched, the emptiness that keeps the night sky dark, is the same emptiness that holds every star apart from every other star, forever, with a thoroughness that no force and no will and no longing could ever overcome. I told you several parts ago that there would be a low place in the middle of this walk, and that I would be honest with you when we reached it, and that I would stay beside you. We are in the low place now. This is it. This is the part where the emptiness stops being a beautiful fact about the structure of galaxies and becomes a heavy fact about isolation. Every star is alone. Not lonely, perhaps, because a star does not feel, but alone in the geometric sense, the structural sense, the sense that matters most, held apart, separated, unreachable to every other star, and unreached by every other star, across gulfs that the architecture of the universe will never allow to close. And you live on a planet circling one of those grains. You are riding a single star through the dark, and that star has its neighbors, every one of them 4 miles away or more in our model, 5 light years away or more in the truth, every one of them visible and none of them reachable, and you are looking out from your grain at all the other grains, across all the gulfs, and the gulfs are not closing, and they never will. Hold that for a moment. I am not going to rush you past it. It deserves to be felt, but I do not want to leave you in the low place, because the low place is not the end of the walk, and it is not even the truest part of the walk. It is one true thing among several, and the others are waiting, and I want to begin, gently, to turn us back toward them. Because there is something on the far side of this isolation, something that the isolation itself makes possible, and I want to point at it now, softly, before we get there. The isolation is what makes the light precious. Think about it this way. If the stars were close together, if the grains were packed shoulder to shoulder, if every star had 1,000 neighbors within easy reach, then the light of any one star would be nothing special. It would be lost in the crowd, drowned in the glare of all the others. One small contribution to an undifferentiated blaze. The light would be cheap because there would be so much of it, so close, so constant that no single source would matter. But that is not how the galaxy is built. The galaxy is built with the grains far apart, with vast gulfs between them, with each star burning alone in its own patch of the dark. And because of that, because of the very isolation we have been sitting with, the light of each star is a rare and precious thing. When the light of your nearest neighbor reaches you across 5 light years of emptiness, it is not lost in a crowd. It arrives as a distinct point, a single clear signal, having traveled alone across the gulf, carrying within it the news of a real other star, a real other burning point, a real neighbor you can know about, even though you can never reach. The light is the one thing that crosses the gulf. Let that land for a second. You cannot send your body across the gulf. You cannot send a sound. You cannot send a wind or a hand or a bridge or a voice. The gulf forbids all of it, but the light crosses. The light, alone among all things, makes the journey. It leaves your star and travels across the 4 miles, the 5 light years, the long quiet road, and it arrives at your neighbor's world, and it tells them you are there. And their light makes the same journey in return, and it arrives at you, and it tells you they are there. The gulf separates everything except the light. The light is the one messenger the emptiness allows. And so the very isolation that holds the stars apart is also what makes their light matter. Because the light is the only thing that crosses, the light becomes precious. Because the gulf is so wide, the thin thread of brightness that spans it becomes the most valuable thing in the architecture. The emptiness that keeps the stars apart is the same emptiness that lets their light travel clear and undimmed across the dark, arriving at last as a clear, bright signal, a message from an unreachable neighbor, the one thing that can cross a gulf that nothing else can cross. We are going to follow that thread in the next part of the walk. We are going to turn, finally, from the emptiness itself to what the emptiness makes possible. We are going to look again at the brightness of the galaxy, the brightness we started with in the very first part, the luminous spiral in the photograph, and we are going to understand it in a way we could not have understood it before. We are going to find that the galaxy is bright, not in spite of the emptiness, but because of it. We are going to find that the brightness and the emptiness are the same fact, looked at from 2 sides. And the low place we are standing in now, the isolation, the unreachable neighbor, the gulf that never closes, will turn out to be the necessary ground on which the brightness stands. For now, stay in the grain a little longer. Stay inside the star. Feel the gulf around you on every side. Feel the nearest neighbor, 4 miles away, 5 light years away, visible and unreachable, looking back at you across the same dark. Feel the situation of it, not the tragedy, the situation. The simple architecture of being a burning point in a structure made mostly of distance. You are alone in the geometric sense, and the light still crosses. That is the whole of it, held in one breath. The gulf separates you from every other star forever, and the light still crosses the gulf, the one messenger the emptiness allows, arriving clear and bright and precious, precisely because it traveled so far alone to reach you. The neighbor exists. The neighbor is unreachable. The light still crosses. Hold that, and we will walk on. Hold the grain again. We began with it, all that time ago, at the start of this walk, a single grain of fine sand on a kitchen table, small enough to lose between your fingers, light enough to lift on a breath. And I asked you then to let that grain be the sun, to let that one small mote stand for the whole burning star at the center of our solar system, with all its planets, including the one you are resting on right now. Pick it up again, in your mind. Set it on the table in front of you. Look at it. You know more now than you did when we started. The grain has not changed. The grain is exactly what it was. But you have walked a long way since you first set it down, and the walk has changed what the grain means, even though it has not changed the grain. So let us walk through it one more time, slowly, gathering everything we have learned, letting the grain hold all of it. The grain is a sun, a body of fire, holding itself together against its own gravity, burning at its core, pouring light into the dark in every direction, steadily, patiently, across billions of years. That is the grain. That is the small, pale mote on your table. The next grain is 4 miles away, not on the table, not in the room, not in the building. 4 miles, across town, on someone else's table, behind a door you have never walked through, and between your grain and that grain there is no second grain to find. There is no scattered dust along the way. There is only the long, quiet road, 4 miles of it in the model, 5 light years of it in the truth, with almost nothing in between. Between them, almost perfect vacuum. Thinner than any emptiness we have ever made in any laboratory on Earth. A few stray atoms of hydrogen per cubic centimeter, far fewer than the best vacuum our finest pumps can produce. A little cold dust, a weak field drifting with nothing to push against. Light passing through in every direction. And vast, vast amounts of nothing in between any one of these things and the next. That is the gulf. That is the road between the grains. Around them, hundreds of billions of other grains, scattered across a disk 100,000 light years wide, each one a sun, each one burning alone in its own patch of the dark, each one 4 miles from its nearest neighbor in the model, 5 light years across the gulf in the truth, each one visible to the others as a point of light, and unreachable to the others across a gulf no body could ever cross. Hundreds of billions of them, set into the dark like rare bright specks across an ocean of distance. And the whole structure, this thin scatter of light across an ocean of emptiness, is what we call a galaxy. Let that land for a second. That is what a galaxy is. Not the luminous crowded spiral of the photograph, dense with packed stars, bright from edge to edge. That was the lie your eyes told you. The soft, necessary lie of the long exposure, which gathers the light of the rare bright grains and smears it together until the emptiness disappears from view. The galaxy is the other thing, the truer thing, the thin scatter of light across the ocean of nothing, the grains, far apart, alone, burning, the gulfs between them, wide and cold and almost empty, the dark overwhelming the light by a margin no mind can hold. The galaxy is mostly nothing. The galaxy is mostly distance. The galaxy is mostly the spaces between, and the light, the brightness, the burning, is the rare and precious exception, set into the emptiness, made visible by the emptiness, made meaningful by the emptiness, the one thing that crosses the gulfs that nothing else can cross. You have walked all of this. You have stood the grain on the table and measured the 4 miles to the next one. You have walked the empty road between them. You have watched 2 whole galaxies pass through each other and seen that the grains do not touch, that the stars slide past one another untouched, because the emptiness is so vast that even a collision is mostly a drifting through. You have looked up at the dark night sky and understood, perhaps for the first time, that the darkness is not nothing, that the black between the stars is the gulf itself, seen end on, the emptiness of the galaxy made visible over your head. You have stood inside a single grain and felt what it is to be a star, alone in the geometric sense, with your nearest neighbor visible and unreachable, looking back at you across a gulf that will never close. And you have seen, on the far side of that isolation, that the light is precious precisely because it crosses a gulf nothing else can cross, that the galaxy is bright because it is empty, that the brightness and the emptiness are the same fact seen from 2 sides. All of it is in the grain now. The grain holds all of it. Hold that for a moment, and now I want to bring you back. Back from the grain, back from the galaxy, back from the long dark gulfs, back into the room where you are resting right now. Notice the room. Notice the surface beneath you, holding you up. Notice the weight of your own body, settled into wherever you are lying or sitting. Notice the air around you, which is not empty the way the gulf is empty, which is thick with quintillions of molecules in every breath, soft and warm and full. Notice your hands, wherever they are, resting at your sides, or folded on your chest, or curled near your face. Notice your hands. Here is the last thing I want to give you, and it is the quietest thing and the strangest, and I want you to receive it gently as you settle towards sleep. The same emptiness is in you, the atoms in your hands, the atoms that make up every part of you, are themselves mostly empty space. At the center of each atom there is a tiny, dense nucleus, and far around it, at a distance enormous compared to its size, the electrons, and between the nucleus and the electrons, almost nothing, almost perfect vacuum, the same kind of emptiness as the gulf between the stars, scaled down, repeated in every atom of your body. If the nucleus of an atom were a grain of sand, the electrons would drift their own great distance away, with nearly empty space between. You are made of grains and gulfs. You are made of points and the vast emptiness around them. The same architecture as the galaxy, written small, written into the substance of your own hands. You are mostly empty space. The galaxy is mostly empty space. The atoms are mostly empty space. And yet here you are, solid to yourself, warm, breathing, held by the surface beneath you, real. The emptiness does not make you less real. The emptiness is what you are made of, and you are real anyway. The same way the galaxy is mostly nothing and burns with light anyway. The same way the grain is a speck on the table and holds a whole sun anyway. Sit with that for a moment. The emptiness is not a lack. We learned this on the walk, and it is true at every scale. The emptiness between the stars is what lets the stars be stars. The emptiness in the atom is what lets the atom be an atom. The emptiness is the room that the something needs in order to be. You are not diminished by the space inside you. You are made possible by it. The gulfs in your hands are the same gulfs as the gulfs between the grains. and they are not absences to be mourned. They are the architecture of your being. They are the room in which you happen. So as you lie here now, in the warm, full air, on the surface that holds you, with your mostly empty hands resting wherever they rest, you are a small piece of the same structure we have been walking through all this time. You are made of grains and gulfs. You are points of matter in a sea of quiet space. You are, in your own small body, an echo of the galaxy, the same emptiness, the same scattered points, the same architecture of distance and light. And the galaxy is turning, slowly, around you, carrying its grain and your grain and all the grains through the dark. Let the walk settle now. The grain is a sun. The next grain is 4 miles away. Between them, almost nothing. Around them, hundreds of billions more. And all of it, the whole thin scatter of light, is the galaxy. It is mostly empty. It is luminous anyway. You are mostly empty. You are here anyway. Let your hands rest. Let the grain rest on its table. Let the galaxy turn in the dark above you, with all its lonely lights, each one burning in its own patch of the gulf, each one sending its thin thread of brightness across the emptiness to whoever is looking. You are one of the ones looking. You have looked far tonight. You have held a sun in your hand and walked the gulfs between the stars and stood inside a grain and felt the dark and understood at last that the dark is what lets the light be seen. Now you can stop looking. Now you can close your eyes. The grain will still be there. The galaxy will still be turning. The light will still be crossing the gulfs, patient and steady, whether or not anyone is awake to see it. None of it needs you to keep watch. None of it asks anything of you now. Let the emptiness be gentle. Let it hold you the way it holds the stars, apart and safe and quiet, with room enough to simply be. Rest now. The galaxy is mostly empty. So are you, and it is enough. Sleep well.